Welcome to the Innovasic Rapid Platform Ethernet IP Network Interface Startup Training. This video will show you how to set up the components of the evaluation kit and how to establish an Ethernet IP connection to the board. A USB flash drive is provided as part of the contents of the evaluation kit. This flash drive contains several files that need to be installed onto the PC. Installation is simply a matter of copying the files into any folder. In this case, we're using a folder that's on the desktop. Once the files have been copied, the USB stick can be removed and we're ready to get started. The next step is to configure the computer to have an IP address that we can use. We do this using the control panel on the computer. The local area connection is the NIC that is connected to our board. We're changing the TCP v4 IP address. We're giving it a static IP address of 192.168.1.5. Also a corresponding subnet mask. When this is done, closing dialogues will set that IP address in the system. Now we need to install a DHCP server. In the tools directory of the files provided, a file called tftpd32 has been provided for this purpose. Install it and accept all the defaults. Once it is installed, it can be configured. You'll notice that you may need to adjust the firewall in the Windows PC. Configuring is simply a matter of setting up the DHCP IP pool starting address, the size of the pool, and the subnet mask. Also, ensure that the DHCP server is bound to the IP address that we assigned earlier. Once you've done this, you'll need to restart the server. Now we're ready to go with DHCP. Shown here are the contents of the evaluation kit. Clockwise from the left are the power supply, the serial cable, the Ethernet cable, the network interface module, and the network interface baseboard. In the center are some jumpers that will need to be installed onto the board. These jumpers are not supplied in the kit. Here we have a closer view of the boards themselves. Next, we will install the jumpers and plug in the module. The jumpers must be installed here. Here, the jumpers are installed. There are a total of 8 of them. Now we will plug in the module. Here it is, installed. Now we will connect the cables. First comes the serial cable. We are showing it used with a serial port adapter because we are using a laptop for our host and it does not have a built-in serial port. Next, the Ethernet cable. And finally, the power supply. We are now ready to test the board. Now we are ready to communicate with the board. First we start the DHCP server. Next we start a command prompt window. Using the command prompt window, we navigate to where the files have been installed. In this case, they are in a directory on the desktop. One of the installed directories is called ni-test.io. Inside this directory is a PC application also called ni-test.io. This application is designed to make the PC act as a host to the board. This command line application requires the name of the PC's serial port. Starting this application starts the host communication with the board. When the board first starts up, it will need to acquire an IP address from the DHCP server. In some cases, the Windows firewall may prevent this. Here we show this being corrected. Now you will see that the board is able to acquire an IP address. Next, we start the Ethernet IP scan tool provided by Pyramid Solutions. Again, the Windows firewall must be adjusted. We are now ready to establish an Ethernet IP connection to the board. First, we add the device, and then a Class 1 connection. For this first connection, the default connection parameters are used. Pressing OK starts the connection. The green boxes show data sent to the board, and the blue boxes show data received from it. In the command window, you can also see the data displayed on the host. Now we can establish a second Ethernet IP connection. For this connection, we will change the Class 1 connection parameters. The data size in both directions will be 4 bytes, and the assembly instances will be 102 and 103. Again, we can use the boxes to show data flowing. Now we add a third connection. For this connection, however, data flows only in one direction. The originator to target size is 2, and the target to originator size is 0. The assembly instances will be 104 and 254. Now we have all three connections active. On the host, the first connection is shown here. The second connection is shown here. And the third here.